Hello everyone, hello students. Today we are going to start. Today I'm going to start with your new chapter. That is the first chapter of physics, and it's motion. Chapter 8, motion. Okay. So first we need to learn certain things. So first we need to learn some terms. So everyone, please pay attention. The first we should learn what is motion, right? So when I say what is motion, it means I'm moving, and I'm moving. When I'm moving, what am I doing? I'm consuming certain time. So what is motion? A motion is say a body is said to be in motion if and only if it changes its position continuously with respect to time. That means if I walk from here to some distance, I will consume some time. If I am performing any activity, that means if I am changing my position at any time but I'm not consuming time, then there is no motion. Can I give you a handshake without taking any time? No, that's not possible. That means whenever I change my position, I should always consume some time. That is, a motion is what is a motion? A body is said to be in motion if it changes its position continuously with respect to time. Okay. Now next is, when do we say that a body is at rest? We say we are taking rest, right? That means what? A body is said to be at rest if it does not change its position. Suppose if I am about to say this pen is at rest, that means what? If this pen does not change its position with respect to time, that means your clock is moving, time is going, it's from 11 to 11:05. Okay, 5 minutes have gone by, but this pen's position did not change. So what will that will be? That will be a body at rest. Okay, now if this pen is moving from left to right and time is also moving forward, that means if I say it takes 1 minute to move from left to right, that means what? This pen is changing its position continuously with respect to time. So that is a body at motion. Okay, so next, whenever a body is moving, obviously it will cover some distance, right? So what is that distance? What is the actual distance? It is the actual length of the path traveled by a body. Suppose this pen is moving forward and then to the left. Okay, so what is the actual path? It started from here, it went forward, suppose 5 meters, and then it went left 5 meters. So what is the distance traveled? The distance traveled is 10 meters. Okay, now displacement is another term that you should pay attention to. What is displacement? Suppose if the pen moved from here, it moved 5 meters forward and then it went left, right? So the total distance was 10 meters. Okay, 5 to the forward, 5 to the left. Now displacement is the shortest path between the initial position from where it started to its final position, right? So what will be the shortest path? It will be the diagonal path, right? So that will be the length of this diagonal, not the actual length of the length of the path that is covered, right? So that is the difference between distance and displacement. Next two terms are very important. One is uniform motion and another is non-uniform motion. Now if this body covers equal distances at equal intervals of time, suppose if this pen's cap is moving equal distances at equal intervals of time, from here to here at 1 minute, from here to here at 1 minute, it covered two equal distances, 5 meters and 5 meters, at two equal intervals of time, 1 minute and 1 minute. So that will be uniform motion. One very good example of uniform motion is your clock, right? The rotation of the earth on its axis. Okay, the earth rotates on its axis. It takes when the earth rotates on its axis, it takes 24 hours. That is, we have one day. Okay, so that is uniform motion. It does not happen like the day is 24 hours, tomorrow your day is 22 hours. It doesn't happen like that. So that is uniform motion. What is non-uniform motion? If a body does not cover equal distances, suppose from here to here it is 5 meters, from here to here 10 meters. Now for 5 meters it took 1 minute, for the next 10 meters it took 1 minute. So unequal distances are covered at equal intervals of time. That is non-uniform motion. The best example of non-uniform motion, to give you a very easy day-to-day example is that, suppose every day you come to school, from the school's gate to the school's classroom, the distance is always same, but every day you will cover the same distance at unequal intervals of time, right? Suppose have you seen smoke? Have you seen smoke? The smoke, the pattern of the smoke, does smoke travel equal distances at equal intervals of time? No. Sometimes the wind blows fast, the smoke will move fast. So those are some examples of non-uniform motion. Okay. So next what we will learn is that speed. Now whenever I'm in motion, I will have some speed, right? So now if this pen is moving from here to here 5 meters at 1 minute, so it will have some speed, right? Now, what is speed? It is the total distance traveled. It is the total distance traveled by total time taken. What is the distance traveled? It is suppose from here to here 5 meters. What is the time travel? The time taken, it is 1 second. So the speed will be 5 meter per second. You can see on the screen it says average speed is equal to total distance traveled by total time taken. What is average velocity? Okay, so whenever I say velocity, I will go to the next slide and then I will point out the differences between speed and velocity. So for velocity, what is the velocity? In velocity, we consider the displacement. It is the total displacement covered by the total time taken. That means if my pen is moving from here 5 meters forward and then 5 meters to the left, the total distance is 10 meters. Okay, but what is the displacement? It is the diagonal path. Okay, so it will be, we consider total displacement. Another, in when mathematically we say it is the average velocity will be your initial velocity by plus final velocity divided by 2. Suppose I tell you this is my initial position. Okay, I'm at rest. So my initial velocity is 0. Suppose I walk from here to here. So what is my, suppose I walk from here to here, then I will gather some speed. I will have some final velocity, right, from this position to this position. So my initial velocity will be suppose 0, final velocity will be 5, and then it will be divided by 2. We get the average velocity. Suppose I throw a stone to the sky, okay, to the sky. So initially I will give some velocity to the stone. Okay, so suppose I throw it at a speed or at a velocity of 5 meter per second. Okay, when the stone will reach to the topmost part, and then it will stop. Okay, from that point it will get back. So what is the final velocity? The final velocity is 0 meter per second. So I have an initial velocity which is more, I have a final velocity which is 0. If I divide them, if I add and divide them by 2, I will get my average velocity. Okay, so next is speed and velocity. Now let us understand the very basic differences and similarities between speed and velocity. As I said, in speed we always consider distance, right? In velocity, displacement is considered. Okay, next is in speed, direction is to be mentioned. Okay, suppose when I say suppose this pen, I'm moving it in a wavy motion. Okay, I'm moving it in a wavy, so can I say its direction is changing at every moment? Here and then like this, and then it goes to the down, and then it will again rise to the top. So at multiple points its direction is changing. So I can say that this pen has an average velocity, right? But when I say speed, I will not consider at what direction. Okay, I will just say the speed of the pen moving is this. Okay, their SI unit will be, in speed and velocity, in both cases their SI unit is same, that is meter per second. Understood? Now let me give you an example. If you have watched a cricket match, you see at the bottom it is written speed of the last ball is 130 kilometer per hour. Okay, so why do they say speed? Because it is impossible to write the velocity of the ball at every time, because when I'm bowling, first the ball goes down and then it moves up, right? So it will change its direction at every point, right? So it is impossible for the person to write the average velocity at every moment. Okay, so they write the average speed. Okay, so they take the total distance from the bowler to the batsman, they take the total distance and then they divide it by time. Okay, so that is your difference between speed and velocity. Next, the topic will be the term that we learn next is acceleration. So whenever there is a change in velocity with respect to time, here it is written, as you can see, rate of change in velocity is called acceleration. Whenever I say rate, whenever I say rate, rate is always change in something with respect to time. Okay, whenever I say rate, rate is always change in something with respect to time. So here rate of change in velocity means change in velocity with respect to time is called acceleration. In the formula you can see below, it says acceleration is equal to change in velocity by time taken. That is, what is the change in velocity? Change in velocity would be my final velocity v minus my initial velocity u, as you can see in the formula, by t. So a is equal to v minus u by t. Clear till now? Now the next two words will be uniform, terms will be uniform acceleration and non-uniform acceleration. In uniform acceleration, it would be if change in velocity is equal. That means if my velocity, suppose initially I am 0 to 10 kilometers per hour, 0 to 10 kilometers per hour at 1 second. In the next second, if I again change my velocity at 10 kilometers per hour, that is 10 to 20 kilometers per hour in the next second, and so on, that is 10, 20 to 30 kilometers per hour in the next second. So in 3 seconds I have taken 30 kilometers per hour, and if I divide them, that is my final is 30 kilometer per hour, my initial was 0 and time taken was 3 seconds. So my acceleration will be 30 kilometer per hour, 30 kilometer per hour divided by 3 seconds. We have to calculate that. Okay, but kilometer, remember boys, kilometer per hour will not be our standard SI unit. Okay, it is not SI unit. The SI unit is meter per second. So what is the unit, SI unit of acceleration? SI unit of acceleration will be meter per second square. Okay, in the top part it is change in velocity, right? In the numerator it is change in velocity, so change in velocity is meter per second. In the denominator it is second, so we get meter per second square. Now non-uniform acceleration is what? If my change in velocity is unequal at equal intervals of time, it is called non-uniform acceleration. Okay, I hope it is clear till here. So we move to the next slide. It is graphical representation of motion. Now we represent those motions in graph. Okay, prior to that I will just tell you two things. Motion, whenever motion happens, it will always happen along a path, right? That means if I need to change my position from here to here, okay, I need a path to travel. Okay, so motion can be in two paths. Okay, as for now, so we will consider motion along a straight path. If my pen is moving in a straight path, it is called motion along a straight path. Now if my pen is moving in a circular path, it will be motion along a circular path. For example, suppose if I tie a ball to a string, right, to a rope or a string, if I tie a ball and then I just give a round motion, okay, so what will happen is that the ball will move in a circular path, right? Okay, now we move to the graphical representation that we will represent the relation between distance, time and speed, velocity in graphs. Okay, in the first case here you will see the first picture, the first graph says the relation between distance and time. Here the distance is plotted along the y-axis and the time is plotted along the x-axis. So you can see for every 20 minutes I'm covering 10 kilometers, right? For the first 20 minutes I'm covering 10 kilometers. For the next 20, that's a total of 40 minutes, I have covered 30 kilometers per hour, right? So next 30, sorry, it's 30. Okay, so that means what? I'm having a uniform speed. This graph is giving me distance and time graph of an object moving with uniform speed. That is, if I'm moving in 10 minutes, if I'm moving 10 kilometers, in the next 10 minutes I'll move another 10 kilometers, right? So I will move 20 kilometers in 20 minutes, right? I will move 30 kilometers in 30 minutes. That is my uniform speed. Okay, so this is the formula where v is equal to s2 minus s1 by t2 minus t1. If you see this graph, you can understand how I am differentiating the distances, the speeds, distances in numerator and the time taken in the denominator. Okay, so s2 is my final distance, s1 is my initial distance, and time 40 is my t2 is my final time taken, t1 is my initial time taken. Okay, now this graph, as you can see, this is not uniform, this is not a straight line. In the earlier graph, the first graph, it was a straight line. That means it was a distance time graph of a object moving in a uniform speed. Okay, now in the second one, you can see it says distance time graph for a car moving along with non-uniform speed. Okay, so when I drive a car, it does not happen that when I drive, as soon as I start my car, I gain a speed of 20 kilometers per hour, and then I travel throughout the road or throughout the path to my destination at 20 kilometers per hour. That doesn't happen. So in real time situations, what happens is that when I start my car, I am at 0 kilometers per hour. Slowly, I will accelerate my car and it will gather speed. It will gain speeds of 10 kilometers per hour, 20 kilometers, 30, and so on, right? So slowly the graph, as you can see, slowly the graph increases with time. Understood? So that's it. Next graph we'll move is, it's called velocity and time graph. That means we are plotting velocity and time here. Okay, we are plotting velocity along the y-axis and time along the x-axis. In the earlier graph we plotted, that was the distance and time. We plotted the distance along the y-axis and time along the x-axis. So in both the cases, the similarity, if you do a comparative study, you can see in both the cases the time term, the time constraint was put on the x-axis. Okay, only the velocity and the distance were put along the y-axis. So here you can see velocity time graph for uniform motion of a car. Okay, so velocity and time graph. Now the car is moving. I have considered here, it is considered that the car is moving along a uniform motion, with a uniform motion. That means as soon as I start my car, it is moving with 40 kilometers per hour, and I will move to my destination at the same speed of 40 kilometers per hour. That means my speed is a straight line along the x-axis, and my time is along the see, this straight line, this means a straight line along the for the y-axis. That means my velocity is uniform, right? And time is gradually increasing. Okay, so this is your relation between velocity and time graph for your uniform motion. Now you have to learn these graphs, because there might be questions, suppose a 2-mark question or a 1-mark question, that draw the velocity and time graph for a uniform motion. Then you have to draw this. Okay, next, and similarly to the prior graphs, the prior 2 graphs, there might be questions like draw the distance time graph for an object moving with uniform speed. Draw the distance time graph for a car moving with non-uniform speed. Understood? Now we move to the next slide. It is velocity and time graph for a car moving with uniform accelerations. Okay, what was acceleration? It was change in velocity with respect to time. That is my velocity, how my velocity changed with time. Okay, now see, initially at 0 my velocity was, at time 0 my velocity was 0. But when I moved to 5 seconds, my velocity was 10 kilometers per hour. When I moved to 10 seconds, my velocity was 20 kilometers per hour, right? So as the time is increasing, my velocity is also increasing in a uniform manner. Okay, that is why the graph is a straight line. Okay, we get a straight line along the graph. Now, what was this graph? This graph was velocity time graph for a car moving with uniform acceleration. So again, here there might be a question, draw the velocity time graph for a car moving with uniform acceleration. Okay, so next is velocity time graph of an object in non-uniformly accelerated motion. Non-uniformly accelerated motion is like, for example, in the real world, you can see people driving cars and riding bikes in a non-uniform manner. Suppose here I find an empty patch of road, I will drive by very fast. Okay, so my acceleration will be very high. Suddenly I get a rough patch of road. If I get bad roads, then my acceleration will be decreased. That means my velocity will decrease, so my acceleration will also decrease. Okay, so these are the two graphs, both are possible. One is deceleration, that is my acceleration has decreased, my speed has decreased. That means my acceleration is in a negative, that is my acceleration is decreasing. In the second case, you can see in the second graph that initially my velocity increased, that means my acceleration was positive. Then my velocity decreased, that means I braked, suppose, that is my acceleration decreased, and again it repeated in another pattern. Okay, so till here what we have studied is that we have studied what is motion. So I said motion is change in position of a body with respect to time. Okay, then motion always happens in two paths. We always need a motion, we always need a path for motion, that is motion along a straight path, motion along a circular path. Okay, now one is uniform motion, another is non-uniform motion. If I cover equal distances at equal intervals of time, it is uniform motion. If I cover unequal distances at unequal distances at equal intervals of time, it is non-uniform motion. Similarly, we have studied average velocity, average speed, a difference between speed and velocity, right? Then we have understood what is acceleration. It is change in velocity with respect to time. Next is what we have studied is these graphs. One is distance time graph, second is velocity time graph. In both the cases, time is always plotted along the x-axis. Distance and velocity are plotted along the y-axis. Okay, so first in distance time graphs we have seen two graphs. One is for a uniform motion, another is for non-uniform motion. Second, in velocity time graphs, first graph was velocity time graph for uniform motion. Okay, next is velocity time graph of a car moving with uniform acceleration. Okay, and then we got two another graphs for velocity time graph, that is for non-uniformly accelerated body. So as for now, you just go through this video, and in the next doubt session we can if you have any doubt, we can just clarify them. Okay, for the next class we will be studying the equation of this velocity time equations, distance time equations. Okay, there are some equations, we will study those. Okay, then we will study how to find velocity time relations, okay, through these graphs and everything. And after that we have a small topic that is called circular motion. Okay, so I hope you have understood till here. If you have any doubt, please note that down and ask me in the next doubt session. Okay, thank you.